All right, mathletes, here's 1.5 circles. Big thing with circles, we want to make sure we understand the standard form of our circle equation. We want to understand how that's related to our center and our radius, and be able to graph those circles from our equations. Some vocabulary. The circle is a set of all points that are a fixed distance r from a fixed point hk, hk being the center, and our radius. As long as we have those two things, a radius and a center, we can deduce where the circle is going to be to graph. All right, so our standard form is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is a radius. Make sure you make note of the subtraction signs there in our general form. So if we were asked to write an equation in standard form with a circle centered at 5, -3 and a radius of square root of 5, it's going to look something like this. X minus 5 squared plus y minus a -3 is going to change that to plus 3 squared, and it's going to be the square root of 5 squared, which will just end up being 5. So that would be my equation for in the standard form of a circle. All right. So if I wanted to look at these equations and make sure I can find the center and the radius, just given this in standard form, notice the center of this one is going to be 3, -5. Radius is equal to the square root of 9, which is 3. Since radius is a distance, we always assume that it's going to be positive here. So here it's x plus 2, so it's going to be x minus 2 is going to be the x parameter of the center. 1 is a parameter of the y parameter of the center, and my r is going to be equal to the square root of 64, which is equal to 8. Here, because I'm not subtracting anything, it's like minusing 0 here. So my x parameter is 0, my y is -3, and my r is equal to the square root of 12. 12 is not a perfect square root, but 4 is. So you can write this as the square root of 4 times the square root of 3 is equal to 2 square roots of 3, making sure we simplify our radical there. Here, this is what we call our unit circle because it's centered at the origin, and it's exactly 1 unit long. And this will become very important next year when you take college trig. All right, so if I wanted to write an equation to describe these circles, I can see that for A, I can see that its intercept here is the y-axis, so that must force this radius to be 4 if the center is 4, 9. So the equation of that circle is going to be x minus 4 squared plus x minus 9 squared equals 4 squared, which is 16, my radius squared. So for B, I can see my center is 4, 0. It intercepts my x-axis at 11, so my radius must be 7. So then here, I'm just going to have x squared. It's going to be x minus 4 squared plus y squared, since I'm on the x-axis, and this is going to be equal to 49, 7 squared. And then C, I can see that intercepts here and here. With the point center at -5 and 5, that forces my radius to be 5. And again, I can get this to be x plus 5 squared plus y plus 5 squared equals 25. So that's being able to look at our graphs and be able to find equations of our circles. So writing equation of the circle, the center at 2, -4, there, and a radius of 3. So I like to kind of look at my radiuses and know that, well, I can count 3 over, 1, 2, 3. So I know I'm going to be there. 1, 2, 3 this way. I know I'm going to be there. Up 1, 2, 3, I know I'm going to be there. Down 1, 2, 3, I know I'm going to be there. And I can get my general circle and graph it there. With this equation, it's somewhat hard just to be able to deduce the intercepts, but I can definitely see that I'm going to have some y-intercepts here, namely in a different color, somewhere around there, somewhere around there. So to be able to figure out what those points are, I'm going to set up my equation, and I'm going to say that I have x minus 2 squared plus y plus 4 squared equals 9. So y-intercepts happen when x is equal to 0. All the values here, x are equal to 0, so I can substitute that in, and I get negative 2 squared plus y plus 4 squared equals 9. I get 4 plus y plus 4 squared equals 9. This should look familiar. It's a quadratic, so in order to solve this, we're going to have to use some tools and resources for solving quadratics. Notice we are expecting 2 answers here. So I'm going to distribute this out and subtract 4 to both sides. So I'm going to get y squared plus 8y plus 16 is equal to 5. Because it's a quadratic, I want to set equal to 0. So I'm going to subtract 5 from both sides. And actually, at this point, if I subtract 5 from both sides, I'm going to notice that y squared plus 8y plus 11 is equal to 0. Well, that's not going to solve nice, so I'm going to try and complete the square. Well, I already had the square completed up here. So I can go back to here and say y plus 4 squared is equal to 5. So now to get my solutions, I square root both sides, and I get y plus 4 is equal to plus or minus the square root of 5. Subtract 4, and I get y is equal to negative 4 plus the square root of 5. And I get y is equal to negative 4 minus the square root of 5. Well, if I look here at my circle, if I have a negative number added to a positive number, this here is going to be my negative 4 plus the square root of 5. And this answer is going to be negative 4 minus the square root of 5. And there are my 2 solutions for the intercepts to that equation. All right, let's go to our next example, 5. So our general form of a circle is ax squared plus by squared plus cx plus dy plus e. Notice x and y first, squared terms first, then you have your linear terms, non-squared terms, and you have your constant, and it's all equal to 0. That's what we're going to refer to as our general form. Our standard form is given here in 5 as x minus 3 squared plus y plus 5 squared equals 9. And what we want to do is now put it into general form. So to do so, we're going to double distribute. So it's x minus 3 times quantity x minus 3 plus y plus 5 times y plus 5 equals 9. So as I distribute this out, I get x squared minus 6x plus 9 plus y squared plus 10y plus 25 is equal to 9. So now I'm going to collect all my like terms. And well, my like terms, it's more or less the order. So my squared terms go first. So I get x squared plus y squared. That's there and there. And then my x terms are going to, and my linear terms are minus 6x plus 10y. That comes from here and here. And then I'm going to have to combine my like terms. I'm going to have a plus 9, a plus 25, and then a minus 9. Well, these will cancel out, so I'll just get a plus 25 here, and this is all going to be equal to 0. So there's my general form of an equation of a line. Not as useful in identifying our center and radiuses, but it will be useful in other contexts. All right, so if I'm finding the center and radius of the circle, again, my general form here, I can't identify it right away, so now I need to go the other way and put it into standard form. So to do so, I'm going to need to complete the circle and do it twice. I'm going to need to complete the circle for my x's, and I'm going to need to complete my circle for my y's. And just to make things a little bit easier for my things, I'm going to subtract 12 over to this side here and make sure I keep that balance throughout my equation. So for my x terms, my perfect square here, I look at my b, it's negative 4 divided by 2, and square it is going to be equal to 4. So this is going to be x squared minus 4x plus 4. And over here, this is going to be equal to negative 12. But because I added 4 here, I'm going to need to add 4 here. Now for my y terms. So it's y plus 2y. So my b term here is 6. So 6 divided by 2 is 3. Squared is 9. So I'm going to have y squared plus 6y plus 9. Go ahead and make sure I add my blank over here to preserve the balance there. So if I've picked these forms right, this here will be x minus 2 squared plus y plus 3 squared is equal to 4. 9 is 13 minus 12 is 1. So my center, my HK value, is equal to 2, negative 3. My radius is equal to the square root of 1, which is just 1. All right. So our other example here, our last example, is find the center and radius of the circle and find the intercepts of any of the graphs from this general form. So first I'm going to have to put it into standard form. So I'm going to concentrate on this, and it's going to be x squared minus 6x, negative 6 divided by 2, and squared is going to be 9, so I'm going to add 9 here, and make sure I add 9 on this side. And then on my y's, okay, I'm going to have y squared plus 10y, and do 10 divided by 2, square it is going to be 25. So I add 25 here and add 25 here to preserve my balance. And I'm going to move this guy over to the other side, so minus 25 here. So if I have this all plus 9 plus 25 minus 25, I'm going to simplify it here. So kind of putting these off to the side here. This should be a perfect square, which is x minus 3 squared, plus this should be a perfect square, y plus 5 squared, which is equal to 9. So the center of my circle is going to be 3, negative 5, and my r squared term is equal to 9. So that means that r is equal to 3. So I go over to here, and I go to 3, negative 5, and I'm there. And I know I can count over 3 for my radius to the right, over 3 to my left, up 3 here, and down 3 here. And I can graph my circle. Looks like it's going to have an intercept right here again with our y-axis. And that y-axis is found when x is equal to 0. So if I go ahead and set x equal to 0 here, I get negative 3 squared plus y plus 5 squared equals 9. Well, when I solve this, this is 9. So I subtract that from both sides. I get 0 here, so I have y plus 5 squared is equal to 0. Square root both sides. Well, I don't have to worry about a negative 0. It's the same thing as a positive 0 when I square root it. And I get y is equal to negative 5. And sure enough, that makes sense with the graph that I had, that it just kissed it and touched it right there on the axes. All right, that concludes our notes for 1.5 circles. Make sure you highlight questions and bring them to class tomorrow.